Hi all. In this video, we'll be checking what are the different classifications of MPPT techniques. So basically, the MPPT maximum PowerPoint tracking is classified into three different techniques: offline, online, and intelligent techniques. And further, more the offline techniques are classified into open circuit voltage and short circuit current. Likewise, online techniques are further classified into perturb and observe, P and O generally we call it as, and the incremental conductance type. Intelligent techniques are further classified into artificial neural network and fuzzy logic control. Now let us see one by one. So this is a simple curve representing current and power. So this is the maximum power point. So the P and O is a general technique or normal basic technique, common technique used for maximum power point tracking. This is because of its simple structure and the ease of implementation. So you can also see that the current drawn by the PV array is perturbated in a given direction, and if the power drawn by the PV array increases, see, if the power increases, the operating point becomes closer to the maximum power point, and thus the operating current should be further increased in the same direction. Also, if the current is increased and this results in a decrease in the power drawn by the PV array, this means that the point of operation is moving away from the maximum power point, and hence the perturbation of the operating current should be reversed. We'll see how do we follow this by just observing this a simple flow chart. So initially in this method, initial value of current I reference is and change in the I reference, del I reference. So first is the reference value I and the change in the reference value. These are taken as the initial values, and then the power that is associated with this current is measured from the PV array and the panel output. That is nothing but this P of K, which is nothing but P suffix PV K, and this is measured from the panel, PV panel. A decrement or increment is applied to the reference current here as a perturbation, which yields a change in the power, and the new power point between the previous one and this is called as the this one, P of K plus 1. The change in the value is the change this one. So once we started the perturbation, increase or decrease is done. So this is the new value. So if they follow this opposite trend, the current reference should be reversed. Okay, the initial value of the current can be 0 or it can be even closer to the maximum power point. So it will be MPP we have seen in the curve, right? So that is the current at the maximum power point. On the other hand, choosing an appropriate incremental step for the I reference, this one, del change in I reference means del I reference can quickly approach the operating point of the to the this maximum power point MPP. So this process should be repeated. So this is what we do here again and again by just selecting this current. So by repeating this again and again until the maximum available power from the PV array is obtained or extracted or found. So this is done repeatedly. The oscillation can be minimized with smaller perturbation steps. However, small step sizes causes the slow response of the MPP tracker. And the next method is the incremental conductance based MPPT technique. So what we do here is, from the name itself, it is easily understood that here it is the sum of the instantaneous conductance I by V and the incremental conductance del I by del V. So this is what we try to do, and this is actually 0 at the MPP, negative on the right side of the MPP and positive on the left side of the MPP. So how do we get it? So it's again the same this technique is being followed, like if the change in current and the change in the voltage is 0 at the same time, so there is no increment or decrement is required for the reference current, And if there is no change in current while voltage change is positive, then the reference current should be increased. So, so like as we have seen in the previous case, previous method, here also there's no change in current while the voltage is likewise. We have to be keen enough that there's no change in current when the voltage is negative. So the reference current should be decreased by that time. Okay, and so this if the current change is 0, well, when there is a difference of like del v by del I is equal to minus of v by I, then in that case then the PV is operating at the MPPT. So this is the simple logic or the algorithm that we try to follow. So we'll have this value change in current or voltage, and that has been checked whether it is equal to 0 or not. If yes, then we'll check whether it is voltage is 0, change in voltage is 0. If then it is yes, then we'll go on with this. If not, then we'll check what is the difference. If there is a change in difference which is equal to minus of V by I, then we'll try to increase it. If it is yes, increment. If no, it is decremented. So again, same here. Okay. So this is the incremental conductance algorithm flowchart. So by just seeing that, you can observe whatever we have seen in the flowchart has been explained here, and so it is just the graph is saying that the change, the dp by dv, the change in power with respect to change in voltage, if it is equal to 0 at this maximum power point, and it will be less than 0 at the right of this side, and it will be greater than 0 at the left of the power point. So this is what is explained in this graph. So this is the power versus voltage. This is current and voltage, power, and this is the change of power with respect to change of voltage. So you will have voltage, current, and change of power with respect to voltage is also shown in this graph. Next method is the fractional open circuit voltage based MPPT. So the first two methods are representing the online MPPT technique, and this is nothing but an offline technique. So this is actually representing the relationship between the voltage at the maximum power point and the voltage at the open circuit of the PV array under varying conditions, temperatures, all these things. So this K1 is, so this is a representation, it is actually linearly dependent, or I can say this maximum power point voltage is actually dependent on the open circuit voltage, linearly dependent, and it is also equivalent to a constant factor K1, which is nothing but the, it depends on the PV array characteristics. So this has to be computed well in advance, and this value of K1 ranges by 0.71 to 0.78. So this is how we try to implement the open circuit based MPPT technique. So we'll have a PV array here, and we'll have a converter, and then we'll track this, we'll have the reference voltage and the actual voltage. This is compared, and we have the PI controller. So generally this array will never operate at the MPP maximum power point. So since in order to match with that, the approximation has to be done, and so we have this controller, and this controller corrects the duty cycle based on which the converter operates, and this is how the power is fed to the grid. Next is the short circuit current based MPPT. So this is IMPP, which is nothing but current at the maximum power point, and this current at the maximum power point is linearly proportional to the short circuit current, which is actually equivalent to the constant factor K2. This is again a factor that is representing, or it depends on the characteristics of the PV array. Like K1, this value of K2 also varies, or it lies between 0.78 to 0.92, and this is how it operates. Same, the PV array will be there, and we have the DC converter, nothing but a chopper, and the actual current is dragged, and with this is compared with the maximum power point, obviously there will be difference, and accordingly the PI controller corrects or produces, or it creates a duty cycle in order to properly make the chopper to work, or the DC-DC converter, which is actually fed to the grid side or the load side converter, which is actually connected to the DC to AC converter with nothing but an inverter. Thank you.